Okay, this video is a continuation of the work started in part 1, where we evaluated this contour integral from -1 plus I to 3 plus 9I along the polygonal line from -1 plus I to 3 plus I, and then up to 3 plus 9I. In this video, we're going to look at the part B, where we're evaluating this integral along the straight line joining these 2 points. So this is the integral we have. In part A, we evaluated it along this contour. So it was a horizontal straight line and then a vertical straight line. We call this C11 and then C12. You can refer to that part 1 video if you want to look at how that worked out. In this case, however, we're going to evaluate this along the straight line joining these 2 points. So remember again, we said -1 plus I is simply the point with coordinates -1, 1, and 3 plus 9I simply the point with coordinates 3, 9. So we're simply going to find the equation of the straight line between -1, 1 and 3, 9. So first thing we're going to have to do is to find the gradient. Well, gradient is going to be 9 minus 1, which is difference in y, over difference in x3 minus -1. So it's going to be 8 over 4. So the gradient is going to be 2. Then the equation is going to be y minus y1. If we use this point, y1 is 1. Then m into x minus x1. So this is now giving us y is equal to 2x plus 2 plus 1. So this is going to be 2x plus 3. Okay, so this is now the equation of our contour. Using this equation, we can express every y in terms of x or vice versa. Remember, in part 1, we said the key to these evaluating this is expressing the integral in terms of one variable using the equation of the contour. So what we want to do here is we're going to look to express everything here in terms of x. So we can write y in terms of x. We could write everything in terms of y, but we already have y here as a function of x. So that is exactly what we're going to do. Now, if I rewrite this, so remember, since z is x plus iy, then dz is dx plus I dy. So that means our integral here is, so we've got the integral from -1 plus I to 3 plus 9I to ix minus y plus 3 times dx plus I dy. So what we're going to want to do is to write everything in terms of x. So that means we need to write this in terms of x, and we need to write that in terms of x. This one is already sorted from here. Is this one we need to work out. So dy from here is simply going to be the derivative of the right hand side, which is 2, and then times dx. So dy is going to be 2 dx. So that means we can now rewrite our integral. So our integral completely in terms of x is going to be 2ix minus 2x, which is this term, minus 3, which is this term, then plus 3, which is this one. Okay, then dx just remains as it is. Dy is 2dx, so we're going to have 2I dx here. And then now this is entirely in terms of x. It's an integral of x, so that means we're going to have to express the limits in terms of the x values. Here x is -1 and here x is 3. So then if we just simplify, the 3's cancel out here, so we're going to have 2ix minus 2x. Here we can factor out dx, so it's going to be 1 plus 2I times dx. But 1 plus 2I is a constant, so we can take it outside the integral sign. So we now have just 2ix minus 2x. It's just an integral of x, so it's going to be 1 plus 2I into ix squared minus x squared when we integrate those ones. If we plug in if we plug in 3, it's going to be 1 plus 2I. If we plug in 3, this is going to be 9I minus 9. Then take away, plug in -1, going to be I minus 1. Then if we simplify this, the i's are going to work out to 8I, and the real terms are going to work out as -9 plus 1, so that's going to be -8. And then we can multiply out here. So if we multiply out, it's going to be 8I minus 8. Then it's going to be -16. 2I times 8I is -16. Then minus 16I. So this is going to be minus 8I minus 24. So that's going to be our final answer. Right, so that's how we evaluate that complex line integral along a straight line, which is at an angle, not horizontal or vertical. We are now going to give you a similar example, just so that you can confirm that you actually understand the method that we are using here. So we want you to evaluate the following. So you are just going to pause the video, work through the integral. So the integrand is exactly the same as before, dz. So this time is going to be from 1 plus I to 3 plus 9I along the straight line joining the 2 points. So that's pretty similar to the example we did before. So if you just want to pause the video, work through this, and then when you continue the video, you can compare with our solution. All right. We now continue to show you our solution for this problem here. As we do that, we'd like to thank you for visiting our channel and watching our videos. We do hope that they are useful to you. We do implore you to subscribe to our channel to support us so that we can produce more. If you've got any questions or any comments, please do post them in the comment section. We'd like to hear from you. If you like stuff, whether you'd like us to do some topics, feel free to just post them in the comment section. All right, so in this case, we are integrating from 1 plus I, which has got x equal to 1 and y equals to 1, so corresponds to the point 1, 1, to 3 plus 9i corresponds to the point 3, 9. So the gradient is going to be 4, and then we find that the equation of the straight line is y equals 4x minus 3. So dy is going to be 4 dx. So if we write this entirely in terms of x, here we're going to have minus 4x and then plus 3, because this 3 is minus here, and then dy is 4 dx. So if you factorize dx here, we're going to have 1 plus 4i. This simplifies to 2ix minus 4x plus 6. So this is a constant. We take it out, and then we integrate this and plug in the limits, and this thing works out to minus 8i minus 36. Okay, thank you.